Now, dear student, chapter number 4, motion in a plane, and today we have the topic that analytical method of the vector addition. And here we will use the concept of the vector, that means triangle law of vector addition. So, mathematically, how can we represent the resultant of the two vectors? Those are acting at the sum angle and the direction of the resultant. Okay, so these are the two basic exercise mathematically we have. So first we will discuss the triangle law of vector addition by the mathematical concept. Okay. So already we have given the basic define of the triangle law of vector addition. So we have given the two vectors A and B, students. So vector A and the B represented in magnitude and direction by the two sides of a triangle taken in same order, and then the resultant represented in magnitude and direction by the third side of triangle taken in a opposite order. So this one is one of the basic statement we have. So for this one concern, we are just taking the simple consideration of the two vector. Those are acting at a some angle to each other. Now I am just taking the two vectors, that is called the vector A and vector B. This is the vector B. Those are acting in a plane. So we have to be choose the one of the geometrical shape. So here just I am choosing the geometrical shape, that is called the triangle. Okay. So I am just representing the one of the another vector, that is called the B, by the second side, which is also along the same order. And we know the resultant is represented by the third side of the triangle taken in a opposite order. So this one is a representation of the resultant we have. Now dear students, whenever you are dealing with the vector, so you must apply the proper arrows sign should be there. Okay, this one is the concern of the vector B, and this one is a part of the resultant we have. And generally we are just whenever we are dealing with the concept of the, that means direction of the resultant with the vector, so it having the angle, suppose we are just imagining the angle that is called the alpha, and I am just approaching the vector A in a forward direction, because I have to be find out the common divergent point for it. So I am just little bit increasing. Okay, and just I am getting the angle between the vector A and the B, that is called the theta. Okay, now I am just giving the basic nomination O, P and Q, and I am just putting a perpendicular, that is called the QN. Okay, this is the QN is that on the OP. Okay, so from this diagram we are just getting the simplest meaning of the portions. Suppose we have that OP in the part of the magnitude, that is called the magnitude modulus of the vector. Okay, or simply you can use the A. Okay, now PQ you can use here, that is called the vector B, that is called the B we have. Okay, now simplest we have ON in the two portion, that is called the OP plus PN. Okay, OP is nothing but it's simply the meaning of the vector A plus PN. Okay, we have to be discuss the meaning of the PN from the right angle triangle PQN. So we will go with this exercise. Okay, now we have the another part, that is called the QN, and we have to be find out the meaning of the QN we have. So here we are just using the basic general concept, that is, and here we have also the OQ is the vector arm, that is the modulus of the vector. Whenever we are dealing the concept of the magnitude, so needed to be apply the vector sign on the particular portion. So this one is a basic representation of the all the things from the given diagram. Now from right angle triangle PQN. So what can we suggest, that if we are just talking about the PN and the QN, so I am just finding that cos of theta is equal to base upon a hypotenuse. Base is nothing but it is simply the Pn, and hypotenuse, that is called the PQ. So simply I can write the meaning of the Pn, that is called the PQ of cos of theta, students. So Pn can be straight in the part of the B of cos of theta. Now similar we have the sin theta, meaning sin theta is equal to perpendicular upon hypotenuse. Perpendicular is nothing but it is simply the Qn, and the hypotenuse is called the PQ we have. Qn is nothing but it's simply the PQ of sin theta. So this is the general meaning we have. Okay, so Qn is equal to PQ, that is called the B of sin theta. So we have got the two general meaning, that is equation number 2 and equation number 3. Okay, now we will use the Pythagoras theorem. And triangle, that means OQN. Okay, so easily I can write that OQ square is equal to ON square plus of, that means QN square. Okay, ON in the two part, OP plus PN whole square plus Qn having its own meaning, already we have discussed here. Okay, now all the thing in front of us, so I am writing one by one. OQ is the concern of the square here, suppose. Now OQ is nothing but it is simply the meaning of the R square. OP in the portion of the vector A plus PN is the B of cos of theta, already we have discussed. Okay, plus Qn and whole square is there. Qn is the B square of and the sine square theta. So this is the one of the portion we have. Now here we have that means R square is equal to A square plus B square of cos square of theta plus 2AB of cos theta plus B square sin square theta. So R square can be stated in the part of that A square plus B square plus of 2AB of cos of theta. R is equal to under root, we have got the general formula of the resultant A square B square plus 2AB of cosine of angle, that angle arises between the two vectors. Okay students, now R is what? Resultant of two vectors, those are acting at an angle theta to each other. Okay, so this one is a concern of the part of the resultant between the two vectors. Okay, now we are just talking about the direction of the resultant. So further we are just asking the help of the geometrical shape which we have drawn here. Now I am just asking further about the right angle triangle OQN, in which we are just easily to get the meaning of the direction of the resultant. Okay, now direction of resultant. Okay, and the direction of the resultant here we have from the right angle triangle OQN, from the triangle OQN, and that is called the concern of the alpha. So tan alpha is equal to perpendicular upon base we have. So it's a general that mean formula we have got from that part. Okay, so I am just showing to you. How can I show to you? Okay, now I am directly approaching towards the diagram. So the direction of the resultant from the triangle OQN, that is called the tan alpha, that is called the perpendicular upon base. Perpendicular is nothing but it is simply the QN, and base is the part of the ON. And already we have discussed in the equations. Okay, ON can be in the two segments, that means OP plus PN students. Okay, so the tan alpha is equal to QN. QN is the, we have, that is meaning of the V of sine theta, and OP is the A, and PN is equal to B of cos of theta. Okay, alpha is equal to tan inverse. Okay, that is called the B of sine of theta upon A plus B of cos of theta. Okay, so in a part of the addition we have the direction of the resultant. So here we have discussed the two different things. Further I am repeating, whenever you are talking about an angle between the two vectors, so there is a need to be find out the common divergent point. Okay, so that's why we have arranging the vector in a forward direction. We are not interested to increase the magnitude of vector A, because we are increasing the del, so it tells simply the we are increasing the magnitude, but we are not interested. Okay, so further we are just using the simply the dislocation rule. Okay, so whenever we are changing the place of a vector in a plane, so it doesn't affect the magnitude. Okay, so that's why we have got the angle between the two vectors, that is called the theta, and the resultant having the angle with the vector a, that is called the alpha. Okay, so these are the two different things we have. Now we are just talking about the three geometrical cases in which the two vectors are acting at the angle of the 0 degree, 90 degree and the 180 degree in the part of the vector addition. Now we have the two part, that resultant and the tan alpha. We have direction of the resultant. So first case we have, if the theta is equal to 0 degree, then vector A and vector B both are parallel to each other and acting along same direction. So this is the physical situation we have. Suppose this one is the vector A we have, this one is the vector B have. This is the physical situation we have. Okay, now we are dealing with the part of the concept. Okay, so what will be the possible resultant? That is called the under root of that, mean A square plus B square plus 2AB and cos 0 having the its value that is called the 1. So simply we have got the meaning, that is under root of that a plus b of whole square. So easily we can get the resultant, that is called the a plus b students. Okay, now we have the another portion, that is called the tan alpha. So as per the notification we are just getting the sign 0. Okay, and a plus b of cos of 0. So easily know that the direction of the alpha is the 0 with the concern of the vector e. Okay, so second one portion we have, suppose we have the theta is equal to 90 degree. Then how can we discuss the meaning of the r and the tan alpha we have? So this is the situation in which we are just getting the two vectors are acting in a plane along the two mutual perpendicular axes where the angle is the theta degree we have. Okay, this one is the vector a and this one is the vector b. So the simply the meaning of the r can be stated in the part of that a square plus b square plus 2ab and cos of 90 degree. Okay students, so this one is the situation we have. So r can be stated in the part of that simply a square plus b square. This is the general meaning we have of the resultant. And suppose we have the tan alpha, so tan alpha can be stated as a b and sin 90 having the its value 1 and a plus b of cos 0. Okay, so cos 90 having the value, so alpha is equal to tan alpha we have, that is called the b upon a. So this is the general and the basic important cases we have up to this level. Now we are talking about the third portion. Now how can we discuss the third portion? A and the b are anti-parallel. Anti-parallel, a and b are the anti-parallel to each other and the angle between them is a 180 degree. This is the kind of the angle we have, that is called the 180 degree. So the resultant can be stated in the part of that a square plus b square plus of 2ab cos 180 degree minus 1. Okay, so r can be stated in the part of that a minus b of whole square, that is called the a minus b. Okay, so tan alpha is equal to b of sine 180 degree a plus b of cos 180 degree. So it although having the direction that is resultant with the a is the 0. Okay, so this is the kind of the portions we have, and I am suggesting you must complete the example number 4.2 on page 71 NCERT. So this is the one of the exercise you will get the standard meaning of the problem. Okay, so that we are just completing these portions, okay, in the exam. Okay, now in the next topic I'll discuss the parallelogram law of vector addition with the concern of the cases. Have a nice day.